Okay, let's talk about how to find the vertex of a parabola. Okay, so we're going to talk about two ways to find the vertex, and then we're also going to show how to graph it. Watch the video carefully, take notes, copying down the problem as I do it, so go through it slowly with me. And then I'll give you a homework video or a homework worksheet that goes after this, and we'll talk about it in class if you have any questions. So there are three ways we can write the equation of a parabola. We have standard form, we've got vertex form, and we've got factored form. Standard form is y equals ax squared plus bx plus c. Factored form is a times parentheses x minus r1 times parentheses x minus r2. And vertex form is y equals a times parentheses x minus h, that parentheses is squared, plus k, plus this other number k. Okay? And you have to be able to go back and forth between the three forms. So we'll do an example where we start in standard form. We'll talk about what's important about standard form, and then we'll put it in factored form, talk about what's important in factored form, and then we'll also show two ways. Well, we'll show you how to complete the square and put it in vertex form. Okay? So this is how you go back and forth between the three different ways. So here's an example. Write this down with me. Let's say I've got an equation, y equals 1x squared minus 2x minus 3. That's called standard form. Ax squared plus bx plus c. So if you have an equation like that, that's called standard form of a parabola or of a quadratic. And then you can, the nice thing about standard form is this number here by itself, always the number by itself is the y-intercept. And that's one nice thing about standard form. It tells you what the y-intercept is. And that y-intercept is going to be where our graph crosses the y-axis. So at -3, you can put a big fat dot there at -3 on the y-axis, because we know the graph crosses that y-axis at that point. We don't know what it's doing, but we know it does cross the y-axis at that point. That's called the y-intercept. The number by itself in standard form is always the y-intercept. And that goes for any polynomial, not just quadratics, but any polynomial. Now, once we have standard form, we can turn it into factored form, and you can do this in a number of different ways. You can guess and check. I'm going to do the x method. So if I multiply the first coefficient times the last coefficient in standard form, I get -3. I'm going to put that at the top. The number of the coefficient in the middle, I'm going to put at the bottom. And then I'm going to look for two numbers here on the side that multiply to the top and add to the bottom. And that's going to be -3 times a +1 multiplies to -3, and it adds to -2. So you got to figure that out in your head, guess and check. Now, once you know that, then you can go over here and say, oh, okay, factored form is going to be x minus the first number, so x minus 3, and then times parentheses x plus 1. So these two numbers here go over here in the parentheses, and they are the roots of this parabola. And what the root means is it's the x-intercept. So standard form gives you the y-intercept, factored form gives you the x-intercepts. And there is also still a 1 here in front. I'm going to write that just so we get used to thinking about that 1 in front. So that 1 up there is also the 1 here. Now, the roots means that this is where the graph crosses the x-axis. So here, the first one is going to, it's minus, so it's actually the opposite sign. -3 means I'm going to put a big fat dot at +3 on the x-axis. +1 means I'm going to put a dot at -1 on the x-axis. So now we've got 3 points of our parabola. And these points are kind of close together, so you can probably assume that they're going to be connected by a line, and they are. All right? So standard form tells us the y-intercept. Factored form tells us the x-intercepts. The only thing we have to find now is the vertex. So how do we find the vertex? There's two ways to do it. Let's do it the easy way first, then we'll do the more confusing completing the square later. So one way to find the vertex is to say, well, um, parabolas are symmetric. So if I know one point on one side and another point on the other side of the parabola, I know the vertex has to be perfectly between those, right? Exactly in the middle. I don't know where exactly, but if I have two x-intercepts, I know the axis of symmetry, the middle of the parabola, is going to be halfway between those two. So if I take my two roots here, 3 and -1, and I find the average of those two numbers, I add them together and divide by 2, I'm going to get the vertex. So 3 plus -1 is 2, and then I always divide that by 2 to get the average, means the x-coordinate of the vertex is going to be at +1. So I go over to the x-axis and I put a dashed vertical line where x is equal to 1. So here's x equals 1. I know the vertex is someplace on that line because it's halfway between these two roots, these two x-intercepts of the parabola. Okay? Now, once I know that, how do I get the y-coordinate? I go back to my standard form. You could use factored form if you want, but if I go back to my standard form, y equals 1x squared minus 2x minus 3, and I put this x coordinate in here for x, I can find out what y is going to equal, right? So it's going to be 1 times 1 squared minus 2 times 1 minus 3 is going to be the y coordinate. So 1 times 1 is 1. Take away 2 is going to be -1. Take away 3 is going to be -4. So that tells me my vertex is going to be at x equals 1 and y equals -4. That point is going to be right here on our graph. So we put a dot there on the graph, and now we can see the parabola comes down and must go like that. Now here's a tricky thing, because the parabola is symmetric. If I know a point on one side, I can always find a point on the other side. So I know this y-intercept right here is at -3. So if I go the exact same distance on the other side of the axis of symmetry from that point, I know I'm going to get another point. So that point there is going to be at 2, -3. And that's going to be on my parabola also. So my graph must look like this. Parabola looks like this. It goes forever, but it comes down here, hits these points, and goes back up there. So that's one way you can graph a parabola. 5 points is usually enough for a graph. Now, let's do the other way to find the vertex, and that is by completing the square. And this is a little bit harder. So we start with our standard form, y equals 1x squared minus 2x minus 3, standard form. And step one is you have to have a 1 in front of the x squared. So if I don't have a 1 there, I'm going to factor out that number and make it like this. So I'll write it like this just to show you. I'll put whatever that number is in front, I factor that out, and I'm going to have x squared minus 2x minus 3 inside the parentheses. So whatever the number is in front of the 1, I factor it out of all the terms and put it in front of the parentheses. So now what I have is I've got 1 times x squared minus 2x, and then I'm going to leave a space here. I'm going to put my minus 3 over here. So this is the same equation. I just have spaced it out a little bit. I've left a little blank there. Now what you do is you take the -2, the middle term coefficient, and I write it down below, and I divide that by 2. And you always divide by 2. Okay? And that's going to equal -1. You're going to do two things with that -1. One of them is you're going to write it down below in a parentheses with the x, and that parentheses is going to be squared. So take the middle coefficient, divide it by 2, and write that in a parentheses down below that's going to have an x in it, and it's going to be squared. The other thing you do with this -1 is you square it, and you write that up above. So I'm going to take the -1 and square it, and that's going to be +1. I'm going to add that up here to the x squared minus 2x plus 1. I can do that. I can add a 1 there as long as I also add a -1 over here. Okay? So you have to, so really I'm just, I'm not doing anything. I'm adding 1 and I'm subtracting 1, so I'm really not changing the equation at all. But what that does is it allows me to say, now this thing here in the parentheses, instead of being x squared minus 2x plus 1, minus 1 minus 3 is going to be x squared minus 2x plus 1, which I can write this thing here, x squared minus 2x plus 1, by adding 1 to it, I've made it into a perfect square that's equal to this thing down here, x minus 1 squared. So x minus 1 squared is equal to x squared minus 2x plus 1. That, we've completed a square there. We've completed this square by adding 1 and made it into a perfect square that I can write as a parentheses squared. Now, over here, though, this part over here, instead of being -3, is now -4. Okay? So the whole thing is still multiplied by 1. I do have this 1 outside the parentheses there, so that whole thing is multiplied by 1. And if it weren't a 1, if it were a 2 or a 5, I'd have to distribute that, and I'd end up with something like this. 1 times x minus 1 squared minus 4 times 1. So that is vertex form of my equation, and what's nice about that is that the number right here is 1. That's going to be the x-coordinate of the vertex. The number right here is -4. That's going to be the y-coordinate of the vertex. So it's just a different way to find the vertex. So that's the second way to find the vertex. And that's why this equation like this is called vertex form. So it's x minus the x-coordinate of the vertex, and then plus the y-coordinate of the vertex. So we're going to practice that. We'll go over and over this, make it a little bit harder, do some harder problems. But that's the general idea. 2 different ways to find the vertex of a parabola. Thanks you very much for watching, and we'll practice.